In this video, we will see how to find eigenvectors when eigenvalues are repeated. Suppose we have a vector A 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Its characteristic equation will be 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda equals 0. After expansion of this matrix, we get a cubic polynomial whose factors will be lambda minus 2 lambda minus 2 lambda minus 8 equals 0. That gives us 3 eigenvalues 2, 2 and 8. Here we observe that these two eigenvalues are repeated, and we will see how to find the eigenvectors when the eigenvalues are repeated. Now for repeated eigenvalue lambda equals 2, we write a minus 2I multiplied by the eigenvector x equals 0 vector O gives us 6 minus 2, 4 minus 2, 2 minus 2, 3 minus 2, that is 1, minus 1, 2 minus 1 and 3 minus 2, 1 multiplied by variables x1, x2, x3 equals 0 column matrix 0 0 0. The row echelon form of the coefficient matrix will be minus 2 1 minus 1 0 0 0 0 0 0. Matrix multiplication gives us 2x1 minus x2 plus x3 equals 0. Here rank R of this coefficient matrix is equal to number of non-zero rows, which is 1 because there is only one non-zero row, and number of variables is x1 x2 x3, that is 3. Therefore there will be 3 minus 1, that is 2 linearly independent solutions. Those solutions we will find as follows. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. We have the linear equation in 3 variables 2x1 minus x2 plus x3 equals 0. In this equation, if we put this x3 equals 0, then we get x3 equals 0 and x2 equals 2x1. Here for convenience, if you put x2 equals 2, then this x1 will be 2 upon 2, that is 1. We write the first eigenvector x1 equals this 1, this 2 and this 0. Next, if we put this x2 equals 0, then we get x3 equals minus 2x1, and conveniently if we put this x3 equals 2, then that will give us x1 equals 2 upon minus 2, that is minus 1. So the second eigenvector x2 will be this minus 1, this 0 and this 2, which can also be written as x2 equals 1 0 minus 2. Further, we can also say that if k1 and k2 are non-zero scalars, then k1x1 plus k2x2 will also be an eigenvector. Next, we will find eigenvector for the third eigenvalue lambda equals 8. For third eigenvalue lambda 3 equals 8, we write a minus 8I equals 0 vector O. This after simplification gives us minus 2 minus 2 2 0 minus 3 minus 3 0 0 0 multiplied by x1 x2 x3 equals 0 matrix 0 0 0. By matrix multiplication we get two linear equations x1 plus x2 minus x3 equals 0 and x2 plus x3 equals 0. This second equation gives us x2 equals minus x3. Now if we put x3 equals 1, we get x2 equals minus 1 from this, and using values of x3 and x2 in equation 1 we get x1 minus 1 minus 1 equals 0. That gives x1 equals 2. So corresponding to eigenvalue lambda equals 8, we get the third eigenvector, this 2, this minus 1, this 1. And as usual, we can argue that if k is a non-zero scalar, then kx3 is also an eigenvector. Let us solve one more example to determine the eigenvalues and the corresponding eigenvectors. We are given vector A equals 2 2 1 1 3 1 1 2 2. the characteristic equation will be determinant 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda equals 0. After expanding this determinant, we get the cubic polynomial equation lambda cube minus 7 lambda square plus 11 lambda minus 5 equals 0. This cubic polynomial can be factorized by using remainder theorem, and after that by synthetic division, which I have discussed in my previous video. So the factors of this cubic polynomial will be lambda minus 1 into lambda minus 1 equals 0. That gives us 3 eigenvalues of this matrix 1 1 5, and out of these 3, these 2 eigenvalues are repeated. Now for lambda equals 1, we write a minus I into x equals 0, that we write as 2 minus 1, that is 1 2 1 1, 3 minus 1, that is 2 1 1 2, 2 minus 1, that is 1. The row echelon form of the coefficient matrix will be 1 2 1 0 0 0 0 0 0. Matrix multiplication gives us the linear equation x1 plus 2x2 plus x3 equals 0. Here rank of the matrix is 1 because there is only one non-zero row in the coefficient matrix and there are 3 variables. Hence there will be 3 minus 1, that is 2 linearly independent solutions. Let us put x3 equals parameter t and x2 equals parameter s. That gives us x1 equals minus 2s minus t from this equation. Now for convenience, if we put this t equals 1 and s equals 0, that will give us x1 equals minus 1. And next, if you put t equals 0 and s equals minus 1 and put in this equation, then we will get x1 equals 2. So therefore, two linearly independent vectors corresponding to lambda equals 1 will be x2 equals this minus 1, this 0 and this 1, which can also be written as 1 0 minus 1, and x3 will be this 2, this minus 1 and this 0, which can also be written as minus 2 1 0. So these are the two eigenvectors corresponding to these two repeated eigenvalues 1 and 1. The non-repeating eigenvalue is 5, for which we can write a minus 5i into x equals O. To write this further, let us write the matrix A, which is 2 2 1 1 3 1 1 2 2. So we can write this as 2 minus 5, that is minus 3 2 1 1 3 minus 5 minus 2 1 1 2 2 minus 5 minus 3. The row echelon form of this coefficient matrix will be 1 2 minus 3 0 minus 4 4 0 0 0. Matrix multiplication gives us two linear equations x1 plus 2x2 minus 3x3 equals 0 minus 4x2 plus 4x3 equals 0. This second equation will be x2 minus x3 equals 0. If we put x3 equals t, then x2 will also be equals t, and from equation 1 we will get x1 plus 2t minus 3t equals 0, x1 minus t equals 0, x1 equals t. Now putting t equals 1, we get x1 equals x2 equals x3 equals 1. So the eigenvector x3 will be 1 1 1, which also follows that if k is a non-zero scalar, then kx3 is also an eigenvector. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.